homework problems in section 1.2. Okay, and it says here in each of the following, list three terms that continue the arithmetic or geometric sequences. Identify the sequences as arithmetic or geometric. In part A, you got the sequence 3, 9, 27, 81, and 243. And you want to find the next three terms. To do that, you have to find out what the common ratio is. We're multiplying by 3 each time. To get the next number, we multiply 3 times 3, you'll get 9. 9 times 3 will give you 27. Times 3 will give you 81. 81 times 3 will be 243. So the next numbers will be 243 times 3, or 729. 729 times 3 will be 2,187. 2,187 times 3 will be 6,561. So 729, 2187, and 6561 are the next three terms in this sequence. Now, is this sequence arithmetic or geometric? Well, we're multiplying by 3 each time, so it will have to be a geometric sequence. Okay. So this sequence is considered to be geometric. Okay, part B in number 1 is this sequence 1, 12, 23, 34, 45. Now, as you can see here, we're adding 11 each time. From 1 to 12, we're adding 11. Add 11 to 12, you get 23. Plus 11 will be 34. Plus 11 will be 45. So the next three terms, if you add 11 to the 45, you get 56. 56 plus 11 will be 67. 67 plus 11 will be 78. So you have 56, 67, 78 as the next three terms in that sequence. Now we're adding 11, so that means when we're adding something, you're going to have an arithmetic sequence. Adding or subtracting the same common number will be an arithmetic sequence. If you're multiplying or dividing a common number, you'll have a geometric sequence. Part C, we have 10, 14, 18, 22, 26. In this case, we're adding 4 each time. Add 10 to the 4, you get 14. 4 to the 10, you get 14. 14 plus 4 is 18. Plus 4 will be 22. Plus 4 will be 26. So plus 4 will be the 30. Plus 4 will be 34. Plus 4 will be 38. So 30, 34, and 38 are the next three terms in this arithmetic sequence. And I just told you what that is, by the way, because since you're adding 4, that will tell you it's an arithmetic sequence. All right, problem number 2. We're going to find, in this case, the 11th term of this particular sequence. -2, -6, -18, -54. We can use a formula for finding the nth term of any geometric sequence. And that's this formula right here. A sub n is equal to a sub 1 times r to the n minus 1. The a sub n is the nth term of any sequence. A sub 1 is the first term of the sequence. The r is called the common ratio, the number that you're multiplying or dividing by each and every time. Okay, so here we're multiplying by 3 each time. From -2, we multiply by 3 to get -6. -6 times 3 will be -18. -18 times 3 will be -54. So the common ratio is 3. That's what this r is going to be equal to, 3. And a sub 1 is the first term. That's -2, the first term in that sequence. We're finding the 11th term in the sequence, so n is 11. So it'll be a sub 11. That's equal to -2 times 3 to the n, which is 11, minus 1. 11 minus 1 is 10, so it'll be -2 times 3 to the 10th power. We first do 3 to the 10th power and then multiply by -2, which will give you -118,098. So the 11th term in this particular sequence will be 118,098. And the nth term of any of this sequence would be this formula, -2 times 3 to the n minus 1. Okay. All right, number 3, the price of a certain new car increases by the same amount each year. The first year it was $22,400, and in the 11th year it was $36,400. In which year will the car cost $43,400? Now let's look at what we already know in this problem. We know the first year, that's A sub 1, is $22,400. Okay. The 11th year, which is A sub 11, that's $36,400. Okay. Now, in which year will the car cost $43,400? That's your A sub n. And by the way, it's increasing by the same amount, so we have to use the formula for the arithmetic sequence. A sub n, that's the nth term of the sequence, that's equal to A sub 1 plus n minus 1 times d. Okay, now next, here's what I'm going to do here. I know A sub 1 and I know A sub n. Here's how I'm going to find out what d is. Okay, compare the difference between $36,400, which is the 11th year, and $22,400, which is the first year. If I subtract those two, that's going to give me $14,000. Now, from the first year to the 11th year, that difference is 10. Divide by 10, you get $1,400. So the car is increasing by $1,400 each year. Well, the price of the car is increasing by $1,400 each year. That's your common difference. So that's your D. So we can substitute those values into this formula right here. A sub n, that's 43,400. So you have 43,400 equal to A sub 1, that's 22,400, plus n is what we're trying to find, so that'll be n minus 1 times d, which is $1,400. And from here, we're going to simplify this. Let's subtract 22,400 from both sides of this equation. 22,400. And in this case, on the left side, you get 21,000 is equal to n minus 1 times 1,400. Now, if I divide both sides by 1,400, that means n minus 1 is equal to 15. Add 1, n is going to equal to 16. Okay, so that's in the 16th year, the car is going to cost $43,400. So that's how we answer that particular problem here. The car will cost $43,400 in the 16th year. Okay. All right, on to problem number 4. You want to know how many terms are there in the following sequence. You have 19, 24, 29, and so on up to 104. Okay, so you have 19, 24, then 29, and so on up to 104. Okay, and we want to find out how many terms are there. Okay, we can use the formula, I think. A sub n is equal to A sub 1 plus n minus 1 times d to find out how many terms. The first term is 19, that's your A sub 1. N is what we're trying to find. The common difference from 19 to 24, we're adding 5. So d is going to be 5. The last term is 104, that's going to be A sub n. Okay, so let's simplify this by subtracting 19 So that means we're going to have, let's see, 85 is equal to n minus 1 times 5. Now if you divide by 5, 17 is going to be equal to n minus 1. Add 1, you're going to get n is equal to 18. Okay, which means 104 is the 18th term in that sequence, which means that there are 18 terms in that particular sequence here of 19, 24, 29, and so on up to 104. Okay, so there are 18 terms in this sequence. All right, problem number 5 is this. You want to find the first 5 terms of the sequence whose nth term is given by the following. And here in this case, negative 8 plus negative 8n plus 6. So that means you take whatever n is, multiplied by negative 8, and add 6 to it. So if the first term is what we're trying to find, that's going to be n is equal to 1. Okay, so that means we're going to have negative 8 times n, which is negative 1, plus 6. So that means negative 8 times negative 8 times 1, that's negative 8, plus 6, that's negative 2. And then the second term, which is n is equal to 2, that would be negative 8 times 2 plus 6, or negative 16 plus 6, which is negative 10. Okay, and then for the third term, which is n is equal to 3, that means negative 8 times 3 plus 6. Well, negative 8 times 3, that's negative 24 plus 6, which is equal to negative 18. And then for the fourth term, which is n is equal to 4, that's negative 8 times 4 plus 6, which would be negative 32 plus 6, or negative 26. And then for the fifth term, that's n is equal to 5, so that means negative 8 times 5 plus 6, or negative 40 plus 6, which is negative 34. Okay, so as you can see, this has a pattern here. We're adding 8 each time. The first term starts off as negative 2, and then you're actually adding negative 8 each time to get the next number. So that sequence, negative 2, negative 10, negative 18, negative 26, and negative 34. And finally, number 6, consider the sequence given in the table below. Find the least number, which is n, such that the nth term of the geometric sequence is greater than the corresponding term of the arithmetic sequence. Okay, so you have to look at the arithmetic sequence and how that pattern runs, and the geometric sequence and how that particular pattern runs. Okay, as you can see here, the first 5 terms are in the arithmetic sequence are 6,331,200, 6,799,500, and continues. Now, if I subtract any 2 consecutive terms, the common difference there of that arithmetic sequence is 468,300. Okay, so let's look at the arithmetic sequence. Now I'm going to copy the 5th term. That 5th term was 8,204,400. So if we add 8,204,400 to the common difference of 468,300, you get 8,204,400 672,700. Then the seventh term, add 468,300. You'll get 9,141,000. Then the eighth term of that arithmetic sequence, just keep adding 468,300. You'll get 9,609,300, and add 468,300. The ninth term will be 10,077,600. Okay, now let's look at the geometric sequence. The fifth term in that geometric sequence is 7,776. Now let's find the common difference here. From 6 to 36, we're multiplying by 6. From 6 to 216, again, we're multiplying by 6. From 216 to 1296, we're multiplying by 3. So the common ratio is 6. So you take 7776 times 6 to get the sixth term of 46,656. Then the seventh term, multiply that by 6, you'll get 279,936. Multiply by 6, you're going to get 1,679,616. Multiply by 6. Again, this will be 10,077,696. And the question that they ask is, when will the geometric sequence be greater than the corresponding terms of the arithmetic sequence? It starts getting bigger at the ninth term, because the arithmetic sequence is 10,077,600 for the ninth term, and for the geometric sequence, it's just a little bit larger than 96. So the geometric sequence is larger than the arithmetic sequence at the ninth term, as you can see in this particular situation. And that should be enough to assist you with the homework in section 1.2.